The first couple lessons are really going to be a review because it's talking about simplifying expressions. Simplifying expressions starts in 6th grade and it just gradually builds little by little. This lesson has a combination of a couple different skills in it that we are going to be covering. So starting with this first little warm-up question. Says Mrs. Thornberry wrote 3 examples of expressions on the board as shown. Using the examples, write your prediction of what makes something a mathematical expression in the space below her examples. So what makes this a mathematical expression? What makes this a mathematical expression? And what makes that a mathematical expression? I'm going to give you 2 minutes. Stand up when you're done. If you finish before the 2 minutes. And if you can only come up with one thing, that's fine, okay? Even if it's just one simple thing, I'm okay with that. Just try to have at least one thing on your paper so that we can share out some ideas. Again, stand up when you are finished. All right, go ahead. Have a seat. So, what is one thing that all 3 of these have in common that makes them an expression? Brielle?
There's numbers.
Okay, so numbers. That's one reason. Okay, what's another reason? What's another reason? All 3 of these are an expression for this particular reason.
Because they all have symbols, like adding.
So operations. Okay. Still haven't said it yet. What do you think here?
All have like negative or positive sign attached to it.
So we're just gonna go with operations. Okay.
Yeah.
We'll go with numbers. There's one big thing that y'all are missing. Ariana? Well, the first one doesn't have a variable. No equal signs. An expression does not have an equal sign. Okay? Gotta remember that. Have to remember that. All right, so we're going to talk about expressions, terms, coefficients, and like terms. Again, all of this is a review from 6th and 7th grade. So, a mathematical phrase that contains numbers, variables, and operations. And I apologize for those of us who write really big. These lines are really small. Like adding and subtracting. So an expression, go ahead and highlight that as much as you can for it to stand out, is a mathematical phrase with numbers, variables, and operations. Now, you might deal with expressions that have multiplication and division as well. It's not just adding and subtracting. And the big thing is it will not have a what? An equal sign. So that's really important. That is what makes an expression, and an equation, an equation. All right, a term is a constant or a variable in an expression. And in parentheses next to this, I want you to write by itself. All right, that means that there's no number attached to it if it's a variable. And if it's a number, there's no variable attached to it. It's just all by itself. And it's separated by a plus and minus.
Mr. Ritchie, please come to the front office. Mr. Ritchie.
All right, a coefficient is the number in front of a variable. So the coefficient itself is not the number and the variable together. It is the number in front of that variable. And then like terms. And this is where your different colors are going to come in today, because I'm a very visual person, and that is how I teach. And when we're finding like terms, we're going to make them the same color. Okay? So it says they must have both the same base or variable and the same exponent or power. So it has to be the same base or variable or same exponent or power. All right, so now we're just going to go through and we're going to do just a couple of examples of each thing. So the first one, it says just give an example of an expression with 4 terms. Now a term is separated by plus or minus. It can be a variable, it can be a coefficient, it can be a constant, it can be anything. All right, I'm going to give you my example. So please write this. 8x minus 9y plus 2 minus 16z. So 4 terms, and each one of these, make it stand out a little bit. Each one of these are a term because why? Why are each one of those a term?
Because they're split up by plus or minus.
Yes. So now I want you guys to come up with something, not like mine, but with 4 terms. So there's an example for you. Now I want you guys to do it. Give me a thumbs up when you're done.
Mr. Ritchie from MakeWorks, please come to the front office or call the front office.
All right, who would like to share? Who would like to share theirs? All right, Ariana.
I put 6b plus 3x plus
say B or B?
B,
So 6B plus
3x
3x
plus 24
plus 24
minus 34y.
minus 34y. Perfect. All right, who wants to share theirs? One more. All right, Nevaeh.
4z plus 6y minus 3 plus 12x.
All right. Why are both of those good examples? Brayden.
Because there's 4 terms.
4 terms, and they're separated by what operations? Addition and subtraction. All right, looking at the next one, it says list all the terms in the expression below. So you can circle them, you can box them, you can highlight them if you want, it doesn't matter. What is a term? If you did the first one, you can do this one. Don't overthink this. What's a term? It could be an X. It could also be what?
A number with a variable behind it.
It can be a number with a variable behind it. What is separating our terms? Adding it. Well, adding and subtracting. So again, circle, underline, highlight, whatever you want to do. Stand up when you have your answer. Shh. If you're standing, you're quiet. All right, so shh, I will move you if I have to keep telling y'all to be quiet as your last warning. What is my first term? 6x. Okay. What's the next one? Be careful with this one. For you? Why is it negative 10y and not just 10y? Yes. Did everybody hear that?
Yes.
All right. Did anybody only put 10y? Okay. Just make sure you add that negative because technically it's negative 10y
Why?
because the negative sign is in front of the 10y.
Oh.
So all you just make sure you carry your negatives. You don't have to carry your positives, but carry your negatives so you know.
Okay.
All right. What's the next term? Yes, Anthony.
What's 13?
13, and then the last one. Cam. 5z. All right, and then the last one, it says list the coefficients of the expressions below. Now, raise your hand and tell me, bless you, what is a coefficient? Again, if you're not sure, it's right here. What is a coefficient? It's the numbers in front of your variables. So this time, I want you to highlight just those numbers. I know it's kind of small, but let's highlight those numbers. And then give me a thumbs up when you are finished. Question?
It's not in front of them. It's like.
Then is it a coefficient? Or is it just a term?
Oh, it's just a term. Messed up.
That's okay.
Highlighter.
Then just cross it out with your pencil. All right, thumbs up when you have what you think is right. Might not be right. It's okay if it's not. We'll fix it. All right, so what is my first coefficient? What's the first one? Brayden? 14. Okay. What is my next coefficient? Richard? Not 7, but negative 7. Make sure you're carrying that negative with them. Brayden, why is 1 not a coefficient?
Is there not a variable behind it?
Right, it's just a term, a constant technically, because it's just a number by itself. All right, and then the last one, Audrey. Not 2, but negative 2. All right, so for number 4, it says give an example of a like term for each of the following. So a like term must have the same variable or same variable in power or exponent, whatever you want to call that little special number. So for an example of this one, it's 13y. All right, I want you guys to do B, C, and D. Stand up when you're done.
Oh, it does? Oh, be different variables, right?
Has to be the same variable. So like this one doesn't technically got 100, so you just have to put it
Oh, okay. Oh. Fine. Did you say it's
Yeah. Okay, so be careful with this one. You gotta keep the same variable next one. So you can put 6h squared, but it's gotta have the variable e. All right. So I gave you an example for the first one. So someone give me their example for the second one. Callie. 7y for the second one. Now, could this one have been a positive number? Yes, this one could have been a positive number, but what had to be the same? The variable. All right, the next one, 200. All right, Jeffrey. 100. So really, it can be any number, right? Positive or negative, it can be any number. Now this last one, got to be careful with this one because if you're looking at the like term definition, make sure you have both of those. Okay? Raiden, what'd you have on your paper? 3h squared. You must have the h squared. You can have any variable you want, but or any number you want, but you have to have the h squared. If it's only h, would that be a like term for D? No, because it's not to the second power. All right, down here it says circle the letter of any card that gives an example of like terms. So you're going to circle, highlight, whatever you want to do it. Give me a thumbs up when you're done for this bottom box, number 5. I do a lot of like up and down and then just thumbs up. All right, Ben, which one, give me one that you circled that was the same. A. Why? Are the variables the same? Yeah, that's why. Okay. All right, what about B? Why not?
Because one of them has the variable.
All right. What about C? Okay. So this one is... And please go ahead, guys, and make sure you're writing these notes so you understand why they are not like terms, because it's important. What about D?
Yes.
Why?
Uh,
Hold on. Why?
yeah, the same variables.
Same variables and same what? Yes. And the last one, E. Why?
Because they have the same
So they are just what? Numbers, and the mathematical word for just numbers are constants.
Yeah.
All right, and I'm actually gonna add, because I'm a visual person, so I'm gonna add for the ones that worked, why they worked. So if you want to add that extra in, you can. If not, just make sure you have the explanations as to why they are or are not. Lord have mercy. Good thing I deal with numbers. All right, so we have not even actually started talking about simplifying expressions. We've just talked about all the different types and parts of the expressions. So slide up to the top part of the next right side. When you simplify anything, what does simplify mean? When you are simplifying, what are you doing? Raising your hands. Ariana? Yes. You make things smaller. Okay, so that's essentially what we want to do with our expressions. We want to make them as small as possible by combining like terms. And when we combine those like terms, we're going to be adding them or we're going to be subtracting them. All right, it says we can simplify algebraic expressions by, like I said, combining like terms. And be careful when you are combining like terms to check the sign that is in front of the term. This is really, really important. You have to carry those signs with you or with that number. All right, so this is an example of finding things that are the same. And we're using objects right now, we're not necessarily using variables. So it says a group of friends went to the movies and bought tickets T, drinks D, and popcorn P as shown. It says use the given variables to write an expression representing the individual items purchased. Not combining them or anything, we're just writing. So how many popcorns do you see? You see 3, right? So you're gonna write P plus P plus P. All right, how many tickets do you see? Okay, so we're gonna do a weird T plus T plus T. All right, and then obviously what's the last thing? Drinks. How many drinks do we see? How many? 3. So plus D plus D plus D. Now, I want you guys to identify the like terms. So someone raise your hand and tell me one term that is the same as another.
P is the same as P.
Okay, so I want you to identify. So you're going to take a color and you're going to be very careful. So you're going to circle or highlight the first P, but then I'm going to include the plus with the second P. Why? Why do I have to do that?
Because it's positive and the plus showing that it's positive.
Right. So, and just like I said here, be careful when combining like terms to check the sign in front. So we're going to include all the signs in front. So whatever color you did, you circled the P, you need to change your color and circle the T's, and then change your color and circle the D's. All right, so right now this expression is extremely long. We want to make this expression as small as possible. So how many P's do you see? How many blue circles or? You said what? Oh, I thought I heard 1. I'm sorry. So yes, you have 3. So it's going to be 3p. How many t's do I have? And am I adding them or am I subtracting them? And how do I know? Raise your hand. How do I know if I'm going to add or subtract? Ben? Yes, the addition sign is telling me that I'm going to add these 3. All right, and then so I can use that same logic for the 3 drinks, right? All right, questions about combining like terms? Questions about making your problems or your expressions smaller? All right, let's do number 6 together. So I have 13r plus 5r plus 2n. Do you guys, raise your hand, see anything that is the same that we can combine? Raiden.
13 and 5.
Not just 13 and 5, but
13
13r and
5
not just 5r
positive.
plus 5r. And then the other one, I'm just going to do in my pencil. Ow. All right, so here I have 13 plus 5. And remember, these are notes, so please show all the steps. If I'm writing, you're writing kind of thing, okay? So 13 plus 5 is obviously easy. It's what? 18. So I have 18r plus 2n. And does everybody understand why it's plus 2n? Is there anybody who doesn't? We're good? Makes sense? All right, we're going to do one more together. All right, number 7. Negative k plus 16 minus 12k. Which ones are the same? Nevaeh.
Negative k and
And what?
negative 12.
All right, so we're going to do negative k minus 1 because an invisible number in front of a variable is just a 1. So what is negative 12 minus 1? Negative 13. K plus 16. That's multiplying. And an easy way, Cam, honestly, an easy way to look at that is think about a number line. So, what was it, negative 12? So negative 12 is there. I'm subtracting 1 from that. So am I going this way towards 0 or am I? So this is going to be my plus, this is going to be my negative. So I just hop 1 to the, which is negative 13. Okay, I mean, honestly, like just visualize a number line in your head and just say, okay, it's going to be this or this. All right, you guys are doing 8, 9, 10, and 11. You must use colors. Stand up when you're done. I'm going to set the timer for 5 minutes. If you need help, please raise your hand or come and ask for help. So it's essentially variables and exponents, then variables, then constants. So this is a constant sign. Alright, you guys got about 48 seconds. 48 seconds. Okay, so remember, first one for me, I will do step by step. So yes, that first one, just don't forget you also have, so it's negative 5, 18, and 7 cents. So you can do all this together and just stop there. This is the same as what you did last time. Is that gonna show you another? That's fine, if that's what works for you. Alright, let's go ahead and go over these. It's okay if you're not finished. So this next one over here, 7m plus 19g minus 10m plus 6g. Alright, first off, stop talking. Get up and move, please. I'm not saying it again. 2 of y'all need to get up and move. I don't care who. Do we have any like terms? Alright, raise your hand and tell me. Tell me one set of the like terms. Start with that. Ben. Alright, so 7m, and you said negative 10m. That's very important that we keep that negative with it. Alright, and then the next one, we have plus 19g and plus 6g. Now, there was some conversations that were had with the 7 and the negative 10. It does not matter, guys. If you set it up as negative 10 plus 7, or if you set it up as 7 minus 10. Does it? Because what do you get with either one of those setups? Negative 3. So if you want to set it up the first way, that's fine. If you want to set it up the other way, that's fine as well. Whatever makes most sense to you. Alright, so that becomes negative 3m. And then what is 19 plus, what is 19 plus 6? 25g. Alright, number 9. Negative 18 and 7/10 b plus 4b minus 3/10 b. Why do you never focus? Alright, are all these the same? They are all the same. Why? What do they have? Huh?
They all have the same variable.
They all have the same variable. So all of these are the same. And you can do it a couple different ways. I'm going to keep it as simple as I possibly can. So when I do negative 18 and 7/10 plus 4, what do I get? Negative 14 and 7/10. And then I have negative 14 and 7/10 minus 3/10. What do I end up with? Negative 15b. Why? Some of y'all are looking at me like, how'd you get that? When you have two negatives, what do you actually do with them? You add them. Okay? So those two negatives you're actually adding. And it goes back to the same one for number 7. If you put it up just like that, you're essentially going to be adding them. All right, number 10, half b minus 9 plus 8b minus 7 minus b plus 14. Holy moly, that's a lot. Tell me which ones are the same. All right, Jeffrey.
1/2.
Okay.
Positive 8b.
Okay.
Negative b.
Perfect. All right, and then you want to tell me the other ones?
Negative
All right, so I'm gonna start with the B's. So I have 8 minus 1, which gives me what?
That's it.
7. And then 7 minus essentially 0.5. Sorry, that's a plus. Just kidding. Plus 0.5. What is it? So 7.5b. Now, we have minus 9, minus 7, plus 14. So the two negatives, minus 9, minus 7, what are we actually doing with them? So the minus 9, minus 7, what do we do with those? You add them. And again, guys, like, I know this seems so elementary, but if you do this and you think to yourself, okay, there's negative 9, I'm subtracting 7 from that negative 9, you're going to always go to the left. Okay? And I'm not asking you to do this on your paper. I'm just asking you to think about, visualize that number line, be like, okay, this is this, and I'm subtracting, or this is this, and I'm adding. Does that make sense? All right, so we end up with, what is that, negative 16? I'm gonna have to write over here in this box because I write too big. All right, so negative 16, and then I'm gonna add 14 here. So what is negative 16 plus 14?
-2.
Is negative 2. No, yes, yes. Negative 2. And again, do you guys understand why? Is there anybody who's like, I'm just a little confused? Promise? Did you just drink her drink? It's all right. Y'all are good. All right. Did anybody get to number 11? Okay, I'm gonna give you about a minute and a half to. Okay, so if you're done, stand up. When you're finished, stand up. Shh. Don't talk about it. Y'all are nice.
Who does that?
Huh?
I remember when, if you didn't have your measure mask on, you couldn't go outside.
Well, if you don't do your homework, you can't go
Where did
outside.
Mr. Nolan go?
Not here.
Where did he go?
He went away.
Oh,
He went away.
he disappeared.
His-
He went to the summer camp, I think.
Oh,
Yeah, he went to the summer camp.
He works at like Sneed's Ferry, Sea Goal something,
Oh.
Camp Sequence States Ferry.
whatever she just said.
Oh.
I know exactly.
All right,
what it
since
is.
we're talking, let's go ahead and go over this. All right, what is the same? What is the same? All right, Raiden.
And you 1.2K, and then positive 0.2K.
Okay. Anything else to say?
Oh yeah, besides half 0.2, and then negative 2.
And then the plus 10 and 9, or yeah, 10 and 9/10 is by itself. All right, I'm gonna do this on my paper because honestly, I don't have enough room. I'm not that neat. So we have negative 1 and 2/10 plus 3/10. So what do we get? Make sure I wrote that correctly. What do we get when we solve this one? Raise your hand. What do we get, Jeffrey? So negative 9/10, and that's K, right? All right, the next one is 5/10 minus 1. So 5/10 minus 1. Raise your hand. What do you get with that one? Brayden, what do you think?
Negative 0.5.
Yep. Negative 0.5, negative 5/10, negative half, whatever you want to call it, and that is G. And then the last one is just a plus 10/9. So when we put that all together, that's what you get. You can either do it this way, so it's a little bit easier to read. So that's essentially what you should have got for your answer.
I'm mixing up the symbols.
Are you not keeping them in the circle, or
No, I'm doing that, but like I'm getting the numbers right, but not the symbols. Like the equation. I added it.
you added it?
Yeah.
So you're not connecting your... I'll look at it in a second. All right. Number 12. This one I want you to do, but I want you to do it with your group members. It says simplify an expression for the perimeter of the rectangle. You're working together with people at your table, and then stand up when you're done. This is a word problem, so I do expect you to annotate it. It's not a very big word problem. All right, stand up when you're finished.
I'm mixing up the symbols. Like, I would like add this because I thought that was supposed to add it to that.
But, like, you know when I did mine, you know how it's or box, I boxed that one separately so that I don't use mine.
Oh.
A negative 1.2 plus 0.
Oh yeah. So yeah.
Right, so make sure with your circles, you are actually. Oh, I'm sorry, absolutely not, you have lost all sense of your mind. I'm not playing with you. That is not working together. So, just erase that part. Your,
The addition symbol. We had a whole number, and it's 2 X's. There's a symbol. But there's no symbol. So what do you do with this one? Because yeah, so there's this one. There's no symbol equals. And this symbol is around. So we're multiplying that. Why?
but are you?
Bro, why
Depends on what you're multiplying. It honestly depends on what you're saying you're multiplying.
well, there's no symbol in front of me in either of these.
So then what are they? If there's no symbol, it's a positive. And what are you find? Find the number. So then you're actually what?
Oh, alright. Thank you. Try to 17. Try to 17.4 plus 6x. 17.4x plus 6x.
You can't combine them. We're still doing combining right now. Right?
Plus negative 8.
Yeah, but it's perimeter, so you have to do it by 2 plays. So I got
6.
46.
6. So 22. So I have a different thing on the 22. So then I multiply that by 2. I added this to this.
Plus 0.6.
You told me, you just told me to.
It's not 0.6, it's really.
Yeah, that was.
Okay, so
If you're putting perimeter, shouldn't you add 6 plus 6 plus 17?
So 23.4 minus 0.8. Because I added this and this as the like terms. And then I started to subtract it because it's in front of this. What?
Wait.
So when I multiply this by 2, what does that give me? Do I just leave that there? Same? So, yeah, 'cause- yeah.
You're good. If you're,
So it's gonna be 46.
if you are done,
minus 1.
if you're done,
Doesn't matter whether we're right or wrong.
if you're done, stand up, guys.
Got it.
You got it?
I understand it.
You sure?
Yes.
You positive?
100%.
All right, you're gonna explain it.
Okay.
All right. So how are you done, but the rest of your group isn't?
Oh no, I'm
I'm talking about Anthony. How are you done, but the rest of your group isn't?
Oh, we're done.
I just didn't write the answer in the box.
So that means you ain't done.
I'm
Oh
done.
Lord Jesus. All right, have a seat. And if you're still working, continue working quietly. All right, Braden, first and foremost, what are we finding?
The like terms or the perimeter.
Thank you. We're finding the perimeter, not area, so be careful with that. All right, next. Braden, what goes down here underneath on the bottom side of my rectangle?
17.4 minus 0.8.
For X.
Or X minus 0.8 centimeters.
Okay. And then what's going to go on the left side?
6x centimeters or cm.
Okay. All right, now go ahead. We're combining like terms, you said, right? So identify all the like terms for me.
17.4x and 17.4x and 6x centimeters and 6x centimeters.
Okay. And what am I doing with all of those? And when you add all of those up, what do you end up with?
I did a different way than this.
That's okay. We should still end up with the same answer, though.
46.8.
Yes.
Or 23.4.
No. Don't change it. 46.8x. And then what else can we combine?
The 0.8 centimeters.
Just 0.8 centimeters?
And the other one.
Just that? Or is there something that needs to go with those?
Negative.
Okay. So then it's going to be a negative what?
Negative 1.6.
So that should be your answer. Thumbs up if you got that right. No? Alright. Alright, so listen guys. So some of us are saying no. So looking at the work, where did you go wrong? Like where, so we added all these because they're all the same, right? This is still just combining like terms. This is not anything crazy. It's just combining like terms with a different concept of perimeter. Y'all learned perimeter in 3rd grade? Like that's how long ago perimeter was. So nothing changes. You're still just combining those like terms. So those of you that got it wrong, did you combine the 17 and 4/10 and the 6s? All right, why not?
Because we forgot to. So like the way I looked at it is I didn't see the x at first, so I thought it was just 17
Okay. All right, that's fine. So, and again, being careful, making sure you're seeing the whole thing. Please make sure if you did not get this right that you copy down the right information. So if you didn't get it right, make sure you get it right. If you got it right, I want you to go ahead. You're folding this paper in half and you're gluing it in on your notes page that we titled to start with today. Please get this down first before you fold and glue in your paper if you got it wrong. All right, so you folded this in half and you're gluing it into your notebook. All right, slide over to the right side, right next to your left side. You're not flipping a page or anything.
I think that's a little bit too late for that.
All right, so a rule. You always start on the left side because that's everything that's always new is left side for us.
Oh, I put the study guide here, and then
Yeah, I did the same thing as regular.
It's okay. It's all right. We'll start over tomorrow. Tomorrow's a new day, right? So if this is not going to be able to be on the right side, just go ahead and write it on the left side. Either way, please get this titled so you know what you're doing on this page, whatever page that is. So it can be, like, if you have to turn the page out, that's fine. Just get this title down. And I'll make sure I give better directions on how to start.
What does that HW stand for?
What do you think? What Jeffrey said? Homework. Yeah, we don't do those anymore. I'm still recording. I'll tell you in a minute. So this is going to be your homework. What I need you to do so that nobody loses this page, I need you to put a touch of glue right underneath your title and you're gluing this sheet in. Okay? You are not doing your work on this sheet. Very rarely will you actually put any work on this sheet. All right? You are going to do the work underneath this sheet. So you're going to do all your work in your notebook right here. Does that make sense? Okay? Now, go ahead and get started. You are working independently. If you have questions or concerns or whatever, hold on, put your pencil down for 1 second. You need to show me whether you're using a different color or whether you're using boxes, circles, squares, whatever you want to call it. You have to show me your like terms here. Do your work on the other, like on this side. So are you doing your work on this page? Do you want to get credit? Then don't do your work on this page. You can write your answer. Do not do your work. All right, go ahead. You have the remainder of the time, which is about 20 minutes. You should get this done. You should end up with no homework today. Jesus, Lord, take the wheel.